sines to find an angle. So I've been given here, I have triangle DEF. Side D is 12, side F is 10, angle F is 50. All right? Find angle D. You know, you could draw a picture. We're going to talk about that a little later, but I'm just going to dive in and see what happens. All right? This doesn't look like it could be that horrible. I know this is opposite angle D, side F is opposite angle F, so it looks like I can just use my law of sines here. So side D divided by the sine of angle D is equal to side F divided by the sine of angle F, which is 50 degrees. Product of the means equals the product of the extremes. I have 10 times the sine of angle D equals 12 times the sine of 50 degrees. Divide by 10, divide by 10. Here I go. Make sure you are in degree mode. 12 times the sine of 50 divided by 10 gave me, as expected, a ratio less than 1. Hey, what happens if you get a ratio greater than 1? Can you have the sine of an angle be equal to something bigger than 1? I think not. Remember, your sine curve goes up and down between -1 and 1. And it's defined to be the side opposite, in a right triangle, the side opposite over the hypotenuse. And of course, the hypotenuse has to be the longest side in the triangle. So if you ever are doing the law of sines or the law of cosines and you get a sine or a cosine greater than 1, you know that the triangle is impossible. It's not a triangle. It can't be done. It can't be done, but it must be done. Okay, that is from some movie. So, but I'm good here. So to undo sine, I'm going to take the inverse trig function, which is inverse sine, second sine on your calculator. And I guess I'll come up here, and my calculator, if I ask it nicely, tells me that angle D is about 66.817-ish, or about 67 degrees. Okay? Should I just circle my answer and say, hey, I'm done? No. Because remember, whenever you are finding the sine of an angle, or you know the sine of an angle and you're finding the angle, you always have multiple options, right? Sine, if I go back to my unit circle, is positive in the first quadrant. It's also positive in the second quadrant. There could be a second possible angle that might work. So, if I am thinking about, just like solving this equation, my reference angle would be 66.817, blah, blah, blah. 66.817, blah, blah, blah. So my second angle of rotation that satisfies this equation would be 180, if I'm in degrees, minus 66.817, blah, 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 which would give me angle D being about equal to 113.1828. or around 113 degrees. Could a triangle have an angle of 113 degrees? Well, sure, if there's room. And yes, indeed, it is possible to come up with two answers, with two distinct measures for angle D. This is crazy. So I took the time to make two different triangles. I think you can agree they're different from each other, and yet they both satisfy these requirements. 12 units, 12 units. 10 units, 10 units. I actually did roughly measure to make sure they were about the same. 50 degrees, 50 degrees. The only thing that's different are these two angles are different from these two angles. But they both work. And by work I mean I have 50 degrees, 113 degrees. Sure, that could create a triangle. If I do a little math, this would be 17 degrees. That would give me 180 degrees total. If I do a little math here, that would give me 63 degrees. I think if you check these using law of sines or law of cosines, you would see that these are both viable, possible triangles. So when I asked you to find angle D, there were two possible solutions. This is sometimes called the ambiguous case. I know it sounds like a Sherlock Holmes story. The ambiguous case. And it's called that sometimes because it's ambiguous what angle D equals. Think back to your geometry days. The ingredients I gave you were a side, the next side, and then the next angle. If you recall, you were not able to use SSA or ASS to prove two triangles congruent. Why not? Because they may not be congruent. I can know the sides are congruent, the next sides are congruent, and the next angles are congruent, but I created two different triangles. So whenever you're using the law of sines and looking for an angle, think about the ambiguous case. You might just have one distinct angle as a possible answer. You might have two. You might even have none. Maybe you're given ingredients that don't create a triangle. Okay? All right, I think these are fun. I hope you do too. I'll see you later.